Okay, question 3. We've got a tree diagram. It says the diagram below shows the probabilities for events A and B, with the probability of A dashed, which is not A, equal to P. And the first thing we have to do is write down the value of P. Now, fundamentally, whenever we've got a split in a tree diagram, these two probabilities must add up to 1. This one's 1/5, so this one must be 4/5. Okay, pop our answer down here. The other probabilities are all filled in. The associated probabilities can also be represented by this Venn diagram. So this is understanding the connection between the kind of 4 ending points here and the 4 different sections of this tree diagram. So I'm going to start with the middle. This is the probability of A, or this area is A intersection B. So Q is the probability of A and B both happening. So that's this top line. This will be Q. Okay. And the probability of A and B, which I could write as A intersection B, with tree diagrams we multiply along the branches. So this is 1/5 times 1/4. So that's 1/20. That's going to go in the middle here, 1/20. All right, this section here then, this is A, but not B. So A, but not B. This probability comes from 1/5 times 3/4, which is 3/20. So that goes here. Next one is not A, but B. So that's going to be this one over here. So I've got 4/5 times 3/8. I could cancel down here, but I'm going to, well, actually, no, I'll try and keep everything as 20ths if I can. So it would be helpful to have that denominator as a 4 and that as a 2. So this is 6/20. I could write it as 3/10, but I'm just going to keep it as 6/20 for now. So we've got common denominators. So I've got 6, 7, 8, 9, 10. I'm expecting the remaining 10/20 to be the bit on the outside. But let's double check. This is not A and not B, which means outside of both of these circles. So here we've got 4/5 times 5/8. Again, I'll just cancel to make the denominator a 20th, and I get 10 there. So that's 10/20. So I filled in the whole thing because it's useful to do that, but specifically this question asks me for Q and R. So that's 1/20 and R is 6/20 or 3/10. Probably will give it as 3/10 there. Okay, find the probability of A dashed given B. Okay, so what does this actually mean? This means the probability of not being in A given that we're in B, or like the probability of A not happening given that B has happened. I think it's easiest to use the Venn diagram to answer this question. You can use the tree diagram, but we're just going to focus on here. So first I'm going to focus on the given B part. This basically tells me that we're inside, we're working within this circle. It's given that we are inside B. So what's the probability that within this it's not A? Well, it's this 1/20 is still inside A, so it's this 6/20 which aren't. So I've got 6/20 out of 7/20, the total of these two. So it's 6/20 out of 7/20. You could flip the second one upside down and multiply, dividing by fractions, or cancel those denominators. It's 6/7. Okay, you can also use a formula here. You could use the formula that the probability of A dashed given B is the probability of A dashed intersection B over the probability of B. So the probability of A dashed intersection B is not A but B, not A but B, so that's our 6/20, and the total probability of B is our 7/20. So we get the same calculation there, same answer.